In this video, we're going to continue our practice with assigning oxidation numbers. So what is the oxidation number of nitrogen in the following compound? Well, let's look at our rules. We know that oxygen usually has an oxidation number of -2, except in peroxide compounds. And as it turns out, we're not going to be even using any peroxide compounds this unit, so we can safely say that oxygen will have an oxidation number of -2. Now we have 2 oxygens, so that's a total of -4. And if we look at number 6, it reads the sum of the oxidation numbers of a compound is 0. This is a compound, so the sum is 0. Now we don't have any rules for nitrogen, nor do we have any rules for sodium. But we do know that sodium, it's located in group 1, and it always has a charge of +1. So we're going to safely assume that sodium has an oxidation number of +1. And we have 1 sodium. Remember, if it has to sum up to 0, if we solve for x, x should give us the oxidation number on nitrogen. So x will be +3. So the oxidation number on nitrogen is +3. What is the oxidation number of manganese in the following? Well, once again, oxygen is usually -2. We have 4 of them, so that's -8. Now we're dealing with a polyatomic ion. It has a charge. So number 7 reads, the sum of the oxidation numbers of a polyatomic ion is equal to the charge of the ion. So all the oxidation numbers must sum up to -2. So if we solve for x, the oxidation number of manganese, that's right, is +6. What is the oxidation number of chromium in the following? Well, once again, we know oxygen is -2. We have 7 oxygens, so that's -14. And we know that the sum has to equal -2. Now, chromium is a transition metal, so we rarely even know what the charge of that is. Potassium, however, always has a charge of +2. So let's assume that potassium has an oxidation number of +1. We have 2 potassiums. We have 2 chromiums now, so that's why it's listed as 2x, because of this 2 here. So if we solve for x, we discover that the oxidation number on chromium is +5. Let's do one more. What is the oxidation number of hydrogen and chlorine in the following? Okay. It says that fluorine is always -1, and other halogens are usually also -1, except when combined with oxygen, and we don't have any oxygen here. So we can say that chlorine is -1. Rule number 5 reads hydrogen has an oxidation number of +1 when bonded to non-metals. And here hydrogen is bonded to the non-metal chlorine. So hydrogen should have an oxidation number of +1. Notice that this is also what you would expect given their charges. Hydrogen's usually +1 and chloride is usually -1. So we can see that oftentimes oxidation numbers and charges are just the same thing. All right, let's look at some half reactions. This is just half of a reaction. So here is silver being oxidized or reduced. Remember your definition. Leo the lion says grr. So if something loses electrons, it gets oxidized. If it gains electrons, it gets reduced. So here we have silver going to silver plus. The way that this silver got a positive charge was by getting rid of its electron. And that's what oxidation is, losing electrons. What about iodine? Now, I recognize that some of these aren't balanced, but that's okay. We're just looking at oxidation numbers here. So this would have an oxidation number of 0, and it goes to -1. So its oxidation number went down. That's reduction. Its oxidation number went down because it gained a negative electron. Went from 0 to -1. Here we have H plus going to just a molecule of hydrogen. So I would say that this has an oxidation number of +1. This is an oxidation number of 0. So how do we go from +1 to 0? What do you think? I would say that that's an example of reduction because we went from 1 to 0. The oxidation number decreased. Now this one's a little more tricky. We want to know, is manganese oxidized or reduced? Well, this will require you to use your rules. Oxygen is usually -2. We have 4 of them, and it has to sum up to -1. That gives manganese a charge on the left of +6 and a charge on the right of +2. So manganese, its oxidation number is dropping by 5. Anytime the oxidation number decreases, that's called reduction.